Hello, my name is Kaspar Althoefer. I'm the director of the Center for Advanced Robotics at Queen Mary. We have projects with the nuclear industry in particular. Here we are interested in creating robots that can go into remote environments because they are radioactive. You cannot send humans there. So we are looking now into new ways to teleoperate. So instead of using just a simple joystick to run the robot in that environment, we are actually using a haptic interface. So the user, the operator, can not only see the remote environment, for example, through a camera, through vision feedback, but also gets haptic feedback, i.e. what the robot arm is feeling, the forces of the robot arm in the remote environment are transferred back to the user, and they can feel what the robot is feeling in the environment. So here we are looking at an exoskeleton, a soft exoskeleton that can be used by a patient, so someone who had maybe a stroke and has not full capability of all the muscles in their hands. When we pressurize these air chambers that are integrated, pressure will be applied to the hands and help the patient to actually close their hands. We can see here a system that is a prosthetic device, so for people who lost their arms or were born without arms. So it is made from silicon rubber, so it's very soft, very flexible, and it has now air chambers integrated, which you can see here in black. And when we actuate them, i.e. put pressure in them, then the fingers start moving, and we can use them, as a robotic hand. So, for example, we can shake hands. At the moment, we are using a so-called leap motion sensor, which is here, and that effectively reads out the movements of Thomas's hand, and these are then used to actuate the robotic hand. We could use, for example, electromyograms, so EMG signals from the amputee, from remaining muscles, to actuate the fingers of the robotic hand. We have been looking at creating a number of different sensors, and so here we have one that comes under the heading of optical tomography. In broad terms, we have a very thin layer of silicon rubber, and through that we shine light. And so we have here a number of black lines. These are actually optical fibers which send the light in there. And then we have also a number of lines here that take the light out again. We can measure it and can see the interaction, the physical interaction of a user with that sensor. If you look at the screen, so when I press on here at some point, then the lights will come off, and that gives us an indication on the location on where we press and the amount of force we apply.